Let us talk about this problem. We are given a string which may contain multiple words separated by space. Our task is to reverse the order of words in the given string. For example, if our input string is welcome to GFG, then GFG is the last word. In our output, it should be the first word. To is the second last word, it should be the second word. Welcome is the first word, it should be last word in the output string. In this string, coding should come first, love should come second, and I should come first. In this string, there is only one word, ABC, so there is no change in this string. Now please pause this video and try to write down a function that takes a string as a character array as an argument and reverses word in the given string. You need to reverse the words in place. You need to modify the same character array in place of using any auxiliary space. Let us first talk about a naive solution to solve the problem. The naive solution is to create a stack, traverse the given string one by one from the first character. You stop when you see a space, right? When you see a space, it means you have seen a word. So what you do is you take all these characters, put them into a string and put this string into the stack. Push the string into the stack, right? So you are going to push welcome first. And after a space, you begin the new word. Then again you see a space, you know that 2 is a word. So you push 2 into the stack. Then you see GFG is a new word. You push GFG into the stack. So this way you get welcome to GFG in this stack, this form. Now what all you need to do is you need to take out these individual words from the stack and append them to an empty string, and that string becomes your answer. So I again make my string empty, then I take out the first word and I make str equal to GFG, then I take out 2 and I make it GFG2, then I take out welcome and append welcome to it. So when I take out a word, before appending the word, I also append a space. So this is how I get the reverse words in the given string using a stack. This solution requires auxiliary space. How much auxiliary space it requires? It first of all requires auxiliary space equal to the number of words, right? Those many entries are required in the stack. Also, it requires auxiliary space for the individual words. And how many characters we have together in all individual words? It's going to be big O of n, where n is the length of the given string. So it requires big O of n auxiliary space. How can we do it in place? How can we do it without using auxiliary space? Now please pause this video and try to think of a solution that works with big O of 1 auxiliary space. Let us now talk about an efficient solution that requires constant auxiliary space. It mainly reverses the words within the character array only. Let's get the idea with this example. So the idea is this: we first reverse the individual words and then we reverse the whole string. That's really interesting solution for this problem. Let's say we have our input string as A, B, C, B, C, D, E, F. This is our input string. Now what we do is we traverse through the string, and whenever we see a space, we know that it's end of a word. So what we do is we maintain begin of a word and end of a word, and between those two things we reverse the individual words. So we reverse the first word, we get CBA. We reverse the second word, we get DCB. We reverse the third word, we get FE. Now once we reverse the individual words and we modify the string to this or character array to this, our task is to simply reverse the whole array or reverse the whole string, and we get the output. Now if I reverse this whole thing, I'll get E, F, then B, then space, then B, then C, then D, B, C, D, then space, then A, then B, then C. So the idea is this: traverse through the given character array, reverse the individual words, then reverse the whole string or whole array. That's the simple idea. Let's now see how does this implementation work. So here is implementation which is written close to both C++ and Java. This is the main function. This is a supporting function. This function only reverses the characters from low index to high index in a character array. In C++, you have a direct function for this purpose. You can call reverse function by passing iterators. For example, I can pass here, instead of calling this, making my own reverse function and calling this function here, I can pass str plus start as first iterator, and I can pass str plus end as this other iterator, and it will reverse the string. Here I've written code which is close to both C++ and Java. So in this code, I am passing character array as an argument, size as another argument. You can skip passing size in Java. You can get the size as str.length inside the function itself. And the swap function is not available in Java, so you can write the simple swap function temp equal to str low, and then str low equal to str high, then str high equal to temp. Right, so this is about syntaxes into both the languages. Now let's see the implementation logic. So what are we doing here? We are traversing through all the characters one by one, right? We have initialized the starting point of the current word as 0. Now we are finding the ending point of the current word so that we can reverse between start and end. So we ignore all the characters which are not spaces. And as soon as we find a space, we know that the characters from previous start to end -1 are forming a word, right? So we simply reverse the word, and we set the starting point for the next word as end +1, and then we keep on doing it. So when we go to the next end, if it's not a space, we keep on incrementing end, and when we find a space, we know that characters from start to end -1 are forming a word, we again reverse them. So this is how we keep on reversing all the words. The one thing to note here is it would not reverse the last word, because you are reversing a word when you are seeing a space after it, but there would not be any space after the last word. So we are explicitly reversing the last word. We reverse the last word. We know that last word would exist from start to n -1, right? The start that we set up here, which is after the previous word, right? After the previous word that we reversed, from that point to n -1, we have the last word. Now we reverse the last word, and after reversing the last word, this is simple code for reversing the whole string. Here is a dry run of this code. Say our string is welcome to GFG. Here G is capital and this G is small. I have intentionally done it so that reverse we can see when it is reversed, right? Now start is 0. N is 14, which is the length of the string, right? 0 to 13 are the indexes, and we have the length of the string as 14. Now we set start equal to 0 and we run this loop. We run this loop from 0 to n -1, which means 13. When we run for 0, we see a character which is W. It's not a space, so we ignore it. We ignore this space, this character also. This is not a space. This is also not a space. This is also not a space. When we come to this space, right? When we come to index 7, this is when we go inside this if condition, right? So we don't do anything for 0, 1, 2, 3, 4, 5, 6. When we see a 7, we go inside this if condition when our end is 7. And what do we do inside this if condition? We reverse the characters from start to n -1, which means 0 to 6. So these are the characters which are reversed, and these are the reversed characters, right? So we get the string as EMOCLEW, EMOCLEW. After reversing these, we set the start equal to end +1. So our start now becomes 8, which is beginning of the next word. I am assuming that all the words are separated by a single space. In case you want to handle multiple spaces, you can easily extend this code. You can, instead of if condition, you can write a while loop. When you see a space, you run a while loop inside it. I am assuming here that all the words are separated by a single space. So in this code, I am not handling the cases when you have multiple spaces between the word. In case you want to extend this code to handle multiple spaces, you can write a while loop inside it, right? And this while loop keeps on running while there are spaces, right? So after start is set to 8, we again run this loop, right? Now we see a T, we ignore it. We see an O, we ignore it. So we don't make any change for 8 and 9. When we come to 10, we see a space. Now when we see a space, we reverse the word from start to end -1. So we reverse this TO, right? So it becomes OT. Now we again do not make any change for these indexes 11, 12, 13. And after 13 our loop stops because we have reached the end of the string or character array. After we have come out of the loop, what we do is we reverse the last word because the last word is not reversed yet. Although we have appropriate starting point of this word is 11, but we have not reversed it because there was no space after it. So what we do is we reverse the last word by simply calling this start to n minus 1, right? We know the start and we know that last word must be till n minus 1. Here I am again assuming that there are no trailing spaces. You can make modifications to this code to handle the trailing spaces as well. So we reverse the last word by making a call to start to n minus 1, and after reversing the last word our string becomes this, right? So we have reversed all individual words at this point after we are finished with the loop and finished with the statement. So this is first phase of our code. We have reversed individual words. Now this is the last phase or the second phase where we reverse the whole string from 0 to n minus 1. After reversing the whole string, we get G, F, G, then space, then T, O, then W, E, L, C, O, M, E. So we get the words reversed. Our original string was welcome to GFG. Our modified string is GFG to welcome. So we have reversed all the words without using an auxiliary array or an auxiliary space of non-constant size. We're just using some constant variables. Let us now talk about some language specific things. If user gives you a Java string as input and wants you to reverse individual words, you can use toChar array to convert the string into a character array, and then you can use this function. And if you wish to get back a string again, you can create a string in Java using character array as a constructor. In the constructor parameter of a string, you can pass this str as this and you can return this string, newly created string after these modifications, right? So this is how you can handle strings in Java, and this is better than using the string object because strings are immutable, and if you use a string and implement this logic, that would be complex. It would be complex even if you use mutable things like a string builder or string buffer. This character array logic implementation in Java is super easy compared to using built-in classes. So if you are given a string as input, you can use these syntaxes to convert a string into a character array. You can use this line particularly, right? And to convert the character array back to a string, you can use this line. Right, so this will be not big of one extra space, it will be requiring extra space because you are copying a string to an auxiliary array and then copying auxiliary back to a new string, but it's still better than using a string object. Now talking about C++ implementation, if you initialize your string or your character array this way using double quotes, then be careful when you are using this function. And if you are using size of operator to get the size of this character array, for example, size of str divided by size of str0, if you are using that syntax to know the size of this character array, then you will have one extra size, because when you initialize a double quoted string and assign it to a character array, C++ compiler by default adds an extra character \0, right? Even if you are not writing it, there will be a \0 at the end of the string. And size of the string will not be 14, it will be 15, right? These many characters total count to 14, we just saw, right? And your compiler will add a \0 and will make the size 15. And if you pass that size as it is, then your whole logic will not work, right? Because your size is not correct, right? So here also you will see problem, here also you will see problems, and here also you will see problems. So to fix this, what you can do is you can pass n-1 as a parameter if you are initializing your input string using double quotes. So this is all about some syntax specific issues, but this implementation is really great. If you have a character array as input, you can reverse individual words without using auxiliary space.